Hi, I'm Mr. Oh Ming Yeo. Okay, I'm going to talk about the addition of non-parallel vectors. Okay, as we all know, right, if we have parallel vectors, we either add them up or we subtract them because they either reinforce or cancel each other totally. Okay, but in the case of non-parallel vectors, right, they do not reinforce or cancel out each other totally. So what we can do, right, is that we can draw a scale diagram to find out the resultant force. Okay, let's take a look at example 1. Okay, I have a point mass represented by the red dot acted on by two forces F1 and F2 with an angle of 93 degrees between them. Okay, so there are two methods in which I can do the scale drawing. Okay, the first method will be tip to tail method. Okay, as the name suggests, the tip of the first force must touch the tail of the second force. So in this example 1, right, the setup fits nicely into the tip to tail method. So we can just draw the forces. Okay, let me draw F1. F1, and there's an angle of 93 degrees between F1 and F2. So what I do is that I take a protractor and I measure here 93 degrees, and I can just draw my F2 going downwards. So how do I find the resultant force? The resultant force will be from the tail of the first force all the way to the tip of the first force. Okay, this will be my resultant force. Okay, now I'm going to introduce the second method, which is the parallelogram method. For parallelogram method, right, make sure that the tails must touch each other. Okay, so in this case, we see that the tail of F1 is not touching the tail of F2. So what we need to do is that we need to shift F1 up such that the tail will touch each other. That means this tail must be shifted up all the way to this position such that the tail of F1 touches the tail of F2, and this angle here, it will be 180 degrees minus 93 degrees. It will give us 87 degrees. Okay, now let us draw the scale drawing based on the parallelogram method. First of all, we draw F2 first. This is F2. Okay, then F1, we shift it up. It will look something like this, and the tail will touch each other with an angle of 87 degrees. Okay, then next thing is that, as the name suggests, we need to draw a parallelogram. So this parallelogram is a construction line, so we use dotted line. So draw a parallelogram. Okay, and the resultant force will be from the point where the tail meets all the way to the other corner of the parallelogram, and this will be the resultant force. Okay, so for either method, right, we will get the resultant force to point in the same direction. Okay, now let's take a look at example 2. Okay, for example 2, we can see that the two tails of the forces are touching each other. So in this case, it will be better for us to use the parallelogram method. So now let me try this. Okay, F1. And F2 with an angle of 60 degrees between them. So now let me draw the parallelogram construction line. So it has to be dotted. Okay, and this will be the resultant force. Okay, now let us try the tip to tail method, okay, we can see that the tail are touching each other. So what happens is that we just need to shift down the F1 such that the tail of F1 touches, no, the head of the tip of F1 touches the tail of F2. So now let me draw F2, and I need to shift F1 downwards. And if I shift F1 downwards, right, it becomes something like this, and this angle here becomes 180 minus 60, it will give us 120. Okay, so F1 will touch F2 with an angle of 120 degrees. So the resultant force will be drawn from the tail of the last force to the tip of the first force. So this will be the resultant force. Okay, now let's take a look at example 3. Okay, for example 3, the head of the two forces, they are together. Okay, they touches at the same point. So if you were to use the tip to tail method, this is how it should look like. That means I have to shift my F2 upward such that the tip of F1 touches the tail of F2. So it will look something like this. So this will be my F1, and then my F2 I shift it upwards. When I shift my F2 upwards, right, it will have an angle of 118 degrees. So this will be my F2, 118 degrees, and the resultant force will be drawn this way, resultant force. Okay, then let's look at how we can draw the parallelogram method. Okay, in this case I have to shift F2 upwards, and I have to shift it to the left such that the tail of F2 touches the tail of F1. So I have to shift F2 somewhere here, and this is actually a pair of alternate angles, and it will be 62 degrees. Okay, now let's try. So let me draw F1 first, and I have an angle of 62 degrees. Okay, now let me draw the parallelogram. And the resultant force will be from the point where the two tail meets all the way to the opposite corner of the parallelogram. This will be the resultant force. Okay, as you can see, the questions can come in different forms. So sometimes it will be better to use the tip to tail method if the forces are arranged such that the tip of the first force touches the tail of the second force. And if let's say the questions comes out such that the two tails are touching each other, it will be better for us to use the parallelogram method. Okay, and please note that for this video clip, right, I'm only showing you an overview of skill drawing methods, and I did not discuss how to use the method accurately. So please refer to the next two videos in order to learn how to draw the tip to tail method and the parallelogram method accurately.